Hello and welcome to a BLT QuickTake video. Today we will be going over getting started with Petalinux 2023.1. Petalinux is a tool made by AMD Xilinx that helps you prepare a Linux operating system for an AMD Xilinx embedded FPGA platform that includes an ARM processor. The supported platforms that include ARM processors are the Zynq series, UltraZynq, and the Versal series of FPGAs. Today we're going to demonstrate getting started with Petalinux using a board support package, or BSP, for the Versal VCK190. So we are going to go to AMD Xilinx's website to the Petalinux download page and find the board support package. At the top of the page here, we see the Petalinux installer. If you do not have Petalinux yet installed, we already have Petalinux installed in this, and so that will not be covered in this video. I'm going to scroll down to the Versal Adaptive SoC Board Support Packages, and we are going to want to download the VCK190 Board Support Package. And then we're going to have that start off in the background. And we're going to come back to VS Code, where we're going to go ahead and get started. So in order to set up Petalinux, we are going to first want to open the settings file for Petalinux. Petalinux is a command line only tool, and so we're going to interact with it through a command line terminal. I'm using terminal within VS Code. So we're going to go ahead, go to the Petalinux directory, and then source the settings.sh file. That is going to go ahead and set up our Petalinux terminals. From here, we can go ahead and run Petalinux create -t project, and then after the S, we will specify the path to the board support package we just downloaded. We're going to give our project a name, and we're going to go ahead and let this build. Building can take a little while as it has to extract everything from the board support package, which is around 2 gigs in size. If we had wanted to use the template flow, which allows us to create the project without a board support package and is required for custom platforms, we would have specified template Versal in the command line. However, when using the template flow, you must specify a hardware XSA from Vivado to actually create the project. However, for a board support package, there is already a hardware XSA included, and therefore, you do not have to include an XSA at this time. Once Petalinux is finished setting up, we're going to go ahead and change the boot image type. We are going to be using SD card boot in order to boot the final system from on the VCK190. And in order to do so, we want to change the package type to be Petalinux image minimal. This changes how the SD card is created. So we're going to type in Petalinux config. Well, first we're going to go into the created Petalinux demo repository, Petalinux config, and then once this opens in the terminal window, we are going to go ahead and go to image packaging configuration, Petalinux initramf image, and we're going to change this name to Petalinux image minimal. From here, that is the only change we need to make for this project. We're going to save that setting and exit, and then we're going to be ready to build. At this point, we would normally add a hardware description, the SSA, but as I said before, we don't need to do that right now because the BSP had one. If we did want to, we could at this time. At this time, if we wanted to change anything in the root file system or in the kernel configuration, we could do so. Matter of fact, we can go ahead and take a look at the options within the root file system. Petalinux offers a number of different configurations for the root file system, including, if we go here, we can see under miscellaneous a list of common Linux commands that we can go ahead and add to our embedded Linux operating system. These embedded packages include Python, GDB, and similar. I have these set as I want already, so I'm going to go ahead and leave those settings as they were. And we're going to go ahead and run Petalinux build. Petalinux build compiles the kernel, the root file system, and gets everything ready for SD card generation. We're going to go ahead and type Petalinux build, simply that, and we're going to type time in the front of it so you guys can see how long it takes. All right, this can take a little while, so I'm going to go ahead and set it run and come back when it's finished. Welcome back, and as you can see, our Petalinux build took just about 30 minutes to complete. At this point, we have a compiled kernel image and are ready to boot our VCK190. First, we need to run the package command to actually generate our boot arguments. So we're going to run petalinux boot uboot. This will create the needed files under the image Linux directory to set up our project. We're going to go ahead and type in the command, run it, and it has generated for us our final build products. If we go ahead and take a look within the build products directory, we can see we have now this images directory. Within here we have a boot.bin file, we have a system.dtb file, we have an image.ub file, and we have a boot.scr file. If we were to put this on an SD card and boot an actual hardware, we would want to take the boot.scr file, the boot.bin file, and the image.ub file and put those on our SD card and format that as a FAT file system. However, if you do not have a VCK190 and you want to see if this will work or not, we can use the quick emulator in order to set it up. What we will do is we will go ahead and type in Petalinux boot, and then we're going to type in Petalinux QEMU boot, and then we're going to type kernel. This will tell it to set up a QEMU simulation with the entire kernel being simulated. From here, we can go ahead and set that up and start running. And while that sets up, I can show you that if we were to set up on actual hardware, we could have run Petalinux boot JTAG kernel. This assumes that your VCK190 is physically attached to the computer over USB. And then we can use JTAG programming to program the FPGA and go straight into uboot. Now, we can specify the kernel flag, which will allow us to boot the entire image directly over JTAG. However, this can take several minutes and may not work correctly for larger OS images. As we see the system skip, we see uboot begin to count down. It's going to go ahead and start in the simulation. We now see the kernel log booting, and we see the kernel log of the system setting up, kernel modules loading. And now we see our root file system configuring. As you see, systemd setting up. And you have to wait just a little bit longer to see boot all the way through. QEMU unfortunately takes a little bit longer than real hardware takes to boot. And then once we reach this prompt, we can type in our login as Petalinux, all lowercase. From here, we can set a password to get into our account. I'm going to go ahead and set a password. And then from here, we have now logged into a VCK190 in simulation. Now that we're in simulation, we can see the current directory, and we can do whatever else we want. And then, once we're done here, we can exit the simulation by typing Control A, and then we're going to type X. So, Control A and X. And that will bring the simulation to a close. Thank you for joining us for this BLT QuickTake video, and hope to see you next time.